dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss about the factors affecting anaerobic digestion, part 2. Actually, last class I have explained you about all the factors that will be responsible for this anaerobic digestion. So first of all, we will discuss about the brief about this anaerobic digestion, like what is this digestion. So anaerobic digestion, we can say that it is a controlled process that will involve microbial decomposition of organic waste in the absence of oxygen. So as per the Municipal Solid Waste Management Manual in the year 2018, India has proposed. So in this manual, they have proposed the actual definition of this anaerobic digestion. So this anaerobic digestion means the decomposition process of the organic waste by some microbial activity and in the absence of oxygen. So as I already told you that absence of oxygen. So in this way, the condition is very much significance for this anaerobic process, because when we will give the perfect condition, then only that bacteria can work better, or this microbial activity can work better, and so we will get the best manure from this activity or biogas by this activity. So it is a process. Anaerobic digestion means it is like a process of decaying biodegradable material in the absence of any terminal like electron acceptor like sulfate, nitrates and oxygen. So anaerobic digestion is it is a process that involves some decaying biodegradable materials, decaying or decomposition of biodegradable materials from the organic waste by the activity of some microbes. So these microbes will be act like a decomposer for this organic waste and the organic matter present in the waste, and they will produce some electron acceptors like some sulfate, nitrate and oxygen. So how this will work, like organic waste will be there. So as we know that organic waste can be decomposed, organic matter, all the organic matter present in the solid waste can be decomposed by some decomposing microbial activity, okay. So this microbial activity can take place in the absence of oxygen. So this is the complete picture of this anaerobic digestion. Like anaerobic digestion, we can say that it is a controlled process, because here oxygen is not available. So other factors like temperature, pH, CN ratio, all should be maintained properly. So when we will maintain all temperature, all the condition properly, then only that bacteria will be able to survive, and then they can do and perform better. And this anaerobic digestion consists of a number of complex biochemical reaction. Obviously, lots of biochemical reaction will be there involved in this process, and it will be carried out by several types of microorganisms. So it will be carried out by some microorganisms. That microorganism will be able to survive in the oxygen absence condition, oxygen free condition, and these microbes can perform better when we will give them better condition for their proper growth. Then only they can perform better, and it will be able to decompose better. So now these are the important factors that will be related with this anaerobic digestion. So in this anaerobic digestion, what happened? Anaerobic digestion is there. So in this process, these are the important factors like temperature, pH, some buffering capacity like alkalinity will be there. Then CN ratio, organic loading rate, OLR is there. Hydraulic retention time, HRT will be there. Then volatile fatty acid. So these are the important factors that will be responsible for this anaerobic controlled digestion process. When temperature will be perfect condition, then only you can get a perfect biogas. Otherwise, if something will be like if temperature will be not favorable for the growth of microbial activity, then the microbes will not be able to survive in that condition. In this way, the nuisance will be created, and the biogas will be not proper biogas, and then what is our aim, will not get the proper biogas. So Next is same the pH. So pH should be maintained between 6.5 to 7. So all condition should be in ideal temperature, ideal condition only. So all factors should be in ideal condition only. Then these will be able to work good and perform good. So now we'll discuss about the CN ratio. Previously I have discussed about the temperature, pH and alkalinity. So this temperature is like a three ranges of temperature is there. First is a 0 to 20 degrees Celsius. 20 degrees Celsius to 45 degrees Celsius, that is called as mesophilic stage. So 0 to 20 degrees Celsius. Okay, this is, and 20 degrees Celsius to 45 degrees Celsius, this is called as mesophilic stage. Mesophilic stage. So this stage is the perfect stage, and more than 45 degrees Celsius to 65 degrees Celsius is the thermophilic stage. So this will be like this thermophilic stage is the highest, is the optimum stage of this anaerobic digestion. So if temperature will become more than 65 degrees Celsius, that condition is also not good. In that condition also this microbe will be not be able to survive. So like that, pH I have discussed, like 6.5 to 7.5 pH is required. So these two, this number of pH will be required. So when if it will be more acidic, then this condition is also not good for the microbes. Like that, if it will be more alkaline, if more basic, that condition is also not good for these micro organisms, because they will be not be able to perform better in this condition. Alkalinity should be also like up to 7.7 or 8 only. If it will be more than 8 or 9, then that condition is also not good for the microbes, because carbonates are going to produce in this anaerobic digestion chamber. So today I will discuss about the carbon-nitrogen ratio. So the nitrogen is a major nutrient required for the growth of microbes and the synthesis of amino acids and protein, which in turn convert into ammonia, a buffer compound for the neutralization of the acidification process. So nitrogen is a major nutrient that will be required for this process, and that will be required for the growth of the microbial organisms also. So whatever the microbes are there, they need proper condition to survive and perform better. In this way, nitrogen is again a major nutrient that is required for the growth of microbes and the synthesis of amino acids and protein, which will be going to convert into ammonia. So these amino acids are there. So this amino acid and protein will be break down into its smaller unit, and it will be going to convert into the ammonia and a buffer compounds of neutralization of the acidification process. So buffer compound of the neutralization of the acidification process. So this is whole like acidification process. When acidification process, as I have discussed in the last class, like this anaerobic digestion will have 4 processes. First is the hydrolysis, then acetogenesis, then acidogenesis, then methanogenesis. So during this acidification process, a buffer compound is required. That buffer compound is going to neutralize the acid condition. So when during this acidification process, more acidic condition will be created. So in that condition, some buffer compound is required. This buffer compound can act, this ammonia is act as the buffer compound, and it will helps in the neutralization of the acidification process. So if what happen, if the nitrogen content is low, then microbial population remains less, and it might have take a longer duration to digest the available carbon present in the substrate. So what happened, where this nitrogen CN ratio is like, if the nitrogen content is going to be low, then the microbial population, the microbes which will be present in this anaerobic digestion chamber will remain less, and it will take a longer duration to digest the available carbon present in the substrate. So the carbon, because in the organic substance, this will be like, this process has done for the organic waste. So organic waste is basically made up of CHNOS. So this carbon, hydrogen, nitrogen, oxygen and sulfate will be there. So this carbon can be reduced, can be decomposed when we will provide the proper CN ratio. So what happen, if the nitrogen content will be low? During the nitrogen content low, the microbial population will remain less, and it will be take very longer duration. It is going to take a longer time to digest the mostly available carbon present in the substrate, And if the nitrogen content is high also, then excess nitrogen leads to the production of too much ammonia that will going to inhibit this anaerobic process. So here we talked about two conditions. If nitrogen content is low, then the carbon will not be able to digest properly. And if the nitrogen content will be high, then it is going to inhibit, it is going to hamper this whole anaerobic process. So that's why this CN ratio maintenance is very much required. So what happened? Carbon here, what the carbon is serving as a source of energy and nitrogen control for the microbial population. So what happened? The ratio of carbon and nitrogen play important role for the effective anaerobic digestion process. So here we'll discuss about the what is the best range of the CN ratio. So this CN ratio best range should be 20 to 35, like 20 carbon and 35 nitrogen. So in this way, this ratio should be maintained properly, and this carbon and nitrogen ratio is play a very important role for the effective anaerobic digestion process. So this CN ratio range should be 20 to 35. Carbon should be in 25, and if nitrogen should be 35. And this will be the suitable, and it will be suitable for all the substrate like protein, carbohydrate. So all the substrate is there, fats, all for all substrate like protein, carbohydrate, fat. This CN ratio is the ideal condition for this the decomposition of all organic matter present in the substrate. That's why 20 and 35 range should be maintained. If carbon ratio, if nitrogen will be low, then the carbon decomposition will not take place properly. If the nitrogen content will be high, then what happens? The growth of the microbial activity will be hampered, and this will be going to hamper the anaerobic digestion whole process. This will be like this CN ratio maintenance is very much required for to make the ideal condition for the CN ratio. So next we'll discuss about the OLR, organic loading rate. The rate amount, the available, it will be like it refers to the amount or rate of volatile matter that is feed into an anaerobic reactor. So OLR refers to the amount of volatile matter that is feed into an anaerobic reactor. So high OLR, what it will do? It will alters the digester environment, inhibiting the microbial activity during the initial stage of acid fermentation. So during the initial stage of acid fermentation process, high OLR will be there. This will be going to alter the digester environment, inhibiting the microbial activity. So the digester where environment inhibiting the microbial activity during the initial stage of acid fermentation. And increase OLR increases acid formers. Acid formers means like what? Hydrolytic and fermentative bacteria. So hydrolytic and fermentative bacteria are there. Their activity as compared to the methane formers, methanogens. So methanogens, that is leading to high production of fatty acid. So if high OLR will be there, like organic loading rate. OLR means organic loading rate. So it is like the amount of volatile matter. Volatile matter means all these organic components. Here volatile matter means organic components. So what happen when this volatile matter will be is the main organic load of this anaerobic reactor. So when the high OLR will be there, this will be going to alerts the digester environment, inhibiting the microbial activity during the initial stage of acid fermentation. And increase OLR, like if OLR, like organic loading rate, if it will be increased, then the acid formers are there, like some fermentative bacteria. So this will be going to produce some methane formers like methanogens, and it will be leading to high production of fatty acid. In this way, more fatty acid will be produced because of high OLR, organic loading rate, and it refers to the total amount of the volatile matter, like some organic compound. And low OLR will leads to the underutilization of microorganisms, like starvation. Starvation condition will be created, because what happens if organic load is very less, because these microbes can work on the organic matter only. So if organic matter will be less, then the underutilization of microorganisms, like some utilization of microorganisms, will go for the starvation condition will be created inside the chamber. So in this condition, what happen? These microbes will not get proper amount of food and they will be going to in the starvation condition. So the hence we can say that it should be optimized based on the type of feedstock and also reactor temperature. See, this OLR is a very important, and it should be minimized, it should be optimized on the basis of the available feedstock and also the temperature of the reactor. So low OLR condition and increased OLR condition both will be like harmful for the microbes, and if it will be if more OLR will be there, like organic loading rate, then it is going to increase the acid formers like hydrolytic and fermentative bacteria, and this activity, and if this type of bacteria will be increased, then the methane production is also going to increase, and then what happen? It is going to increase the fatty acid amounts also. Likewise, if the OLR is low, then the microorganisms will be like leading to a very slow growth rate of anaerobic digestion, and starvation kind of condition will be created inside the chamber. Therefore, the OLR should be optimized based on the type of feedstock and also the temperature reactor temperature. Next, we will discuss about the hydraulic retention time. So, hydraulic retention time is the average time that the organic substrate remain in the digester. So, hydraulic retention time refers to the average time on which the reactor will work, up to which the reactor will work. So, it will be like some organic substrate is there inside the chamber, and that will be remains in the chamber. And HRT affects the biological and chemical properties of organic substrate. This is going to affect the biological as well as chemical properties of the organic substrate. It play an important role in anaerobic digestion process, especially for methanogenic bacteria in mesophilic temperature range. So this HRT is like hydraulic retention, total hydraulic retention time. This represents the total organic substrate, the time at which the organic substrate remains in the digester. And HRT affects the biological and chemical properties of organic substrate, and this HRT will play an important role in anaerobic digestion process, especially for the methanogenic bacteria in mesophilic temperature range. And it will be desired to be long enough to provide sufficient methanogens activity. So this HRT will be like this much of long, so it will be able to provide sufficient methanogens activity. Sufficient, it will be like methanogens will need sufficient time. So this will be like that much of longer that it will be enough to provide the sufficient methanogen activity. So in generally, what we can say for this HRT, it is like a shorter for anaerobic digestion at higher temperature, and but mostly depend upon the properties of the feedstock. HRT is basically shorter for anaerobic digestion in high temperature condition, and it will be longer if temperature will be less. So in lower temperature and in higher temperature it will be shorter, and lower temperature it will be longer. Obviously temperature will be more, so if temperature is more, so the bacteria can work better, because we already discussed that these bacteria can work better during the mesophilic and thermophilic stage. So if we'll provide temperature up to 65 degrees Celsius, in that temperature, those microbes can be work better. So if your temperature is more, microbes will work better. So the degradation process will also run fast. In this way, the reactor time will also reduced. So this HRT means what? It is the total timing that will be taken inside the chamber for this anaerobic condition and organic for this organic materials. So this anaerobic at the high temperature, but mostly depend upon the properties of the feedstock. Obviously, what type of feedstock is there, what type of organic waste is there, it will be mostly depends upon this feedstock. So this HRT should be like organic substrate that remains inside the chamber is called as hydraulic retention time. The average time that will be taken by the organic matter to decompose inside the chamber. And HRT mostly affects the biological and chemical properties of organic substrate, and this HRT will play an important role in anaerobic digestion process, mainly for the methanogenic bacteria in mesophilic temperature range, and it is desired to be long enough to provide sufficient methanogens activity. In general, HRT is shorter for anaerobic digestion at high temperature, and it will be longer, vice versa will be there, but it will be mostly depend upon the properties and the types of feedstock that is provided into this chamber. So now we'll discuss about the volatile fatty acid. So volatile fatty acid are all acid forming bacteria. Volatile fatty acid can be produced by these acid producing bacteria. So these acid forming bacteria are there. So accumulation of volatile fatty acid will always affect the anaerobic digestion process by lowering the pH and suppressing the methanogens. So it will be mostly affect the anaerobic digestion process by lowering the pH and suppressing methanogens. So during the acidogenesis phase, two volatile fatty acid will be there. That will be like acetic acid and butyric acid. So acetic acid in this process, acetic acid, and next is the butyric acid. So what they both will do, they both will be favor for the production of methane, and methane is the ultimate gas we want at the end of this reactor. So this volatile fatty acid is produced by acid forming bacteria. This acid forming bacteria will accumulate and in the anaerobic digestion process, and by lowering the pH and suppressing methanogens, and this will be produced during the acidogenesis phase, because these are the acidic in nature. So during the acidogenesis phase, these two acid will be produced called as butyric acid and acetic acid. So acetic acid contributes towards the almost 70% of the methane formation. This acetic acid will contribute to the production of 70% of methane in the whole process. So volatile fatty acid will be like the acid forming bacteria, and it will be produced by the anaerobic process, and it is going to affect the anaerobic digestion process by lowering pH and suppressing methanogens. So during the acidogenesis phase, two volatile fatty acid will be produced. First is the butyric acid and acetic acid, and mainly this acetic acid will be contributes to almost 70% of the total methane formation. So 70% of the total methane formation is only by the production of this fatty acid, acetic acid. And some other volatile fatty acid are like propionic, valeric acid, isobutyric acid, and isovaleric acid. So propionic acid, valeric acid, isobutyric acid, and isovaleric acid. So volatile fatty acid concentration is a good indicator for the monitoring of performance of anaerobic process like the activity of acetogenic and methanogenic, because this volatile fatty acid will leads toward the production of methane. So volatile fatty acid will leads toward the production of methane. Production of methane. That's why this will be a very important stage, and this all are because of two bacteria, that is acetogenic bacteria, and next is the methanogenic bacteria. So two bacteria are involved in this volatile fatty acid. This first one is like a propionic acid, valeric acid, isobutyric acid, and isovaleric acid, and its concentration is a good indicator for the monitoring of performance of anaerobic digestion process and activity of acetogenic and methanogenic bacteria. These two bacteria will lead to the formation of the methane. Now we'll talk about the relationship of volatile fatty acid with alkalinity. So let us consider an example of anaerobic reactor which showing the variation in the concentration of alkalinity and volatile fatty acid with digestion time. So this green color will represent the alkalinity and red color will represent the volatile fatty acid. This will the concentration of the reactor in mg per liter. So this graph shows that the digester has a very good buffering capacity, because the alkalinity and volatile acid both are at the same level. and low volatile fatty acid accumulation at 200 mg per liter compared to the alkalinity of 2000 mg per liter. So this will be like consider the example of this anaerobic reactor. One reactor is there where alkalinity, green color will represent the alkalinity, it is 2000 mg per liter, and volatile fatty acid is a 200 mg per liter. So this will, what it will represent, it will represent that it will be having, this digester will be having a very good buffering capacity. Then only it will be able to degrade, it will be able to degrade all the it will be leads to the degradation of all the organic component present in the solid waste. So this will be the example of anaerobic reactant, that is showing variation in concentration of alkalinity and volatile acid, fatty acid with the digestion time. And next we'll talk about this comparing, when we will compare the volatile fatty acid with the pH. With the pH, then what happen? We will consider, let us consider three different situations of alkalinity and volatile acid, fatty acid of the same reactor at the time A, B and C. So three timing will be there. You can see that A, B and C. So in this three timing, we will discuss about the three conditions. First one is the alkalinity condition, volatile fatty acid, and then pH. So reactor will be like, if here what happened, reactor will be having, reactor A is having like the at time B with increased volatile fatty acid and decreases alkalinity, but the pH still remains stable. And the reactor pH stable at A, like alkalinity is more than volatile fatty acid. And here again one condition will be there. You can see that this condition, in this condition what happened, the volatile fatty acid is more than the alkalinity. Then the what is the condition? The condition is that the reactor naturally buffer and becomes insufficient. Reactor, what happened? This reactor will naturally buffer and become insufficient. So the pH of the reactor starts to fall. So the pH of the reactor will start to fall because what happened? The reactor will be naturally buffer and become insufficient, and the pH of the reactor starts to fall. Here again you can see that this condition is already also there. In this condition, what happened at this time? The increase in volatile fatty acid and decreasing alkalinity, but pH will remains the same. So in this way, alkalinity is more than the volatile fatty acid. So this graph represents the three different situation of alkalinity and volatile fatty acid. Here we want to make a relationship between the volatile fatty acid and volatile alkalinity, and the pH and its relation with the pH. So three reactor will be there. If the volatile fatty acid is more, then what happen? Alkalinity is more, then the pH will be like decreasing alkalinity, and pH still remains the same. Same in the C condition, what happen? Volatile fatty acid is more than the alkalinity, and the reactor with the natural buffer become insufficient, so the pH of the reactor starts to fall. pH of the reactor is going to be decreases. Next point is the reactor pH stable at the A condition, and the alkalinity is more than the volatile fatty acid. So now comes to the next slide. Here we'll discuss about the volatile fatty acid comparison with the methane production. So in the methane production, what happened in the biogas? This is the concentration in mg per liter. Four condition we are considering, four things we are considering, like alkalinity, volatile fatty acid, then methane and carbon dioxide production. So comparing the same reactor condition at A, B and C with biogas production. So A, B and C, three condition will be there, and in which alkalinity and volatile fatty acid will be there. So methane production, so at the time you can say that this is the B condition. In B, what happened? No change is there in this. And the C, what happened at the C? But the time, after time, carbon methane production ceases. After some time, the methane and carbon production will be ceases. It will be ceased. Okay, it will be ceased in this condition. Alkalinity for this B reactor, and then it will be going down for the C reactor. Like that, volatile fatty acid is going to be more for all these three conditions, for all these three reactors. So these are some of the references which I have used for this study. You can go to this textbook. You will read all about this in the details, because these are the main textbook for this solid waste management. Okay, so like this, at this time I want to conclude my lecture on the remark that in this slide, in this lecture series, I have discussed about the solid waste management. So in solid waste management, we are at the point of the transformation of waste. So the transformation of waste will leads toward the how the waste can be transformed from its toxic condition to a normal condition. So in this transformation, we are discussing about the conversion of organic waste into some useful biogas. So for this, we are discussed about the anaerobic digestion. So anaerobic digestion is a condition where all the microbial activity will be there, and that is going to be decomposes the organic matter present in the waste in the absence of the oxygen condition. That's why the condition of this pH, this anaerobic digestion chamber is very much important, because to maintain the perfect temperature, perfect pH, perfect alkalinity is all important. CN ratio and all these factors are connected to each other. If anything will be not maintained properly, then the chamber will be not act properly. So all factors are equally responsible for this anaerobic digestion process. Okay, so if you have any queries or any doubt, you can write in the comment box, or you can direct mail me on my given mail ID, shikha.pandey@gmail.com. Okay, so thank you for this lecture.
Like, share and subscribe. Hit the bell icon for more updates.